This is the agenda. Okay, we have the title, but what are we really going to talk about here? I want to start with some reflections. Like I say, I've been in the Agile space knowingly since '99. I had done some things in the '80s that were a precursor to Agile, but I'd never really thought about it explicitly, to be candid, until I think I was at a conference in OOP, I think it was. It was the one in Munich anyway, '99, and I got an introduction to extreme programming by Barton Fowler there. Uh, and I'm going to reflect a little bit because I think the industry needs to shift a bit, and it hasn't. I'm going to talk about the importance of looking at success and stakeholders, which I think is ignored a little bit or quite a bit. What is engineering and why do we need it? What I'll call the science of knowledge work. I'll talk about lean and flow and theory of constraints a little bit. How to deal with complexity. There's a lot of conversation about we're in complex systems, so we can't predict, we can't know what to do. And I actually think that's disempowering. And I want to talk about how we deal with it using things we've learned, um, the need for decision frameworks. This is maybe a different way or new way of talking about things that have been around for a while and looking a little bit to the future. Uh, so as we do this, I have time for questions. As I was telling Susan, what I'd like is if you don't understand something I said, either I didn't speak it clearly or the sentence didn't make sense to you, or if you disagree with it, I'd like you to ask the question uh, and we'll try to deal with those right away. If it's a question of how would I use this to something in the future, say, hold those to the end because I might answer it later in the talk and that'll help keep us focused. Um, okay, so some reflections, like I say, and I think it's important to do this on a frequent basis, is to look at things. And one of the biggest reflections, perhaps, is that I actually uh, noticed that I used to do things on and off that I then later learned people called them agile and all that. I'm not saying I was doing agile in the '80s, but I do remember doing some automated testing in '84, '85 for some avant-garde work I was doing. And then I didn't use it for years, which was really bizarre because it was so useful. So when XP came out, it wasn't like I was doing XP before that. No, I wasn't. I'd done a lot of the individual practices, but having it defined and explained made a huge difference. And I immediately liked it because, well, I'd done all the pieces. And the lesson here is that sometimes knowing what to do at a tacit level where you just kind of do it is not as good as knowing what to do at an explicit level where you talk to people about it and you understand why. So this is a lot of, again, how we build models and understand something. So just as a little history, Scrum came out in '95, and it was based on a 1986 article, the New Product Development Game. And in the New Product Development Game, they were talking about how does a team of whoever's building a product build the product. That was the new product development game. So one thing you have right here is to recognize Scrum, which is our earliest and most popular agile method right now, was based on a team building new products, which is not quite where it's used all the time now. In fact, I'd say it's almost not used very often in building new products as much as creating enhancements to products, extending existing products, maintaining products. And it's very often not a full team doing it, not an autonomous team doing it. And that's what it's designed for. And things change a lot. And yet we don't always change with it. '99, I may not be the exact year, but I think it was, that's when I was introduced to it. If it wasn't '99, it was the late '90s, '97, '98 with a C3 project by, uh, the payroll system for Chrysler. And what's interesting is this was actually a failed project. I'm not saying XP, I love XP. So I'm not saying XP is a failure. In fact, XP wasn't the failure, but XP was only about building the product. It never got actually implemented and deployed, even though it was way superior to the product that they were trying to replace. It had no bugs. The other one did, or it had way fewer. I don't know if it had none, but it was almost none. And whenever there was a discrepancy between the two, it was the old system was making a mistake. But there's actually a big lesson to this. The big lesson is just building software isn't the point. Getting deployed value is the point. So this actually was further reflected in a sense when the Manifesto for Agile Software Development, sometimes just called the Agile Manifesto, came out. If you read the Manifesto for Agile Software Development, It's very team oriented, very software oriented. Duh, says software development. Uh, doesn't mention management at once. Uh, doesn't have really any systems thinking in it. It was very attuned to what we needed at the time. Okay, I was pretty engaged. We were trying to, at this time, we were trying to figure out what was this thing we were all doing that we didn't have a name for. So when the name Agile came out, that was great. But I've always viewed the Agile Manifesto as a map to the territory of what we're going after, not the definition of the territory. A lot of people think it is the territory. Well, I tend to disagree. That's not how I think about it. Um, I don't think of it that way. And was a very good statement at the time. I don't have this up here, but at 2011, they had what they called Snowbird 10. The Agile Manifesto took place in a ski resort called Snowbird in Utah. And at 2011, they had many of the people who are at 2001 there, and myself and Dave Anderson and a few others, because we were invited because we had worked on the Kanban piece. I didn't invent Kanban, but I was big in the Kanban community at the start, having co-created Lean Kanban University, which is now Kanban University, and I'm not affiliated with it. And we couldn't get any real agreement. We had 21 people there, I think, and we couldn't get any agreement about it. So things had already started splitting up as to what Agile meant. Okay. Now, I kind of jokingly talk about Agile at Scale in 2005, and this is a personal perspective. I just remember we had a client where we've been doing Scrum for, I don't know, 4 or 5 years prior to this point. When I say we, I mean Net Objectives was my company I'd formed in '99. Oh yeah, actually just to put that history in 2019, I was bought by the PMI or the IP of Net Objectives. It was bought by the IP, and I said I left a few months ago. So a lot of this work was done pre-PMI, and some work has been done in the PMI when I was there. But anyway, I remember in 2005, we were trying to we had an engagement where they had something like 3 Scrum teams, and we could not figure out how to get them to work together. And we'd heard of Scrum of Scrums. Now, by the way, Scrum of Scrums is different now than what it was back then. Back then, Scrum of Scrums was the Scrum Masters would coordinate with each other and decide what to be worked on, which sounds a little funny when you think about it, because that sounds like the product owner role. And we couldn't get that to work. We actually came up with something we called the product coordination team around this time. It was in our book, Lean Agile Software Development, Achieving Enterprise Business Agility or something like that. Achieving Enterprise Agility. Can't remember the exact title. But in there, we came up with a product coordination team, which said, no. What you need to do is you need to get the product owners together. They coordinate what the work is, and then give it to the teams. And we also did things like shared backlogs back then. So we had a lot of experience in Agile at what I call small scale, the 40 to 70 people working together, a few teams. It's really not hard if you're guided by Lean. And back then, our president, Alan Shalloway, a lot of these ideas we came up with were then, he came up with and I worked with. Uh, the Scaled Agile framework, I mentioned them because they're also popular. Now, there are other frameworks. Last, I think it was 2005 or so, and Disciplined Agile is out. But right now, I would say Scrum and SAFe are pretty much the 2 big players. So that's why I mentioned their history. But I want to make this reflection, this point. Agile frameworks are not agile themselves. That should be a lowercase a, I suppose. By that, I mean they haven't changed a lot. Scrum in '99, when I first learned about it, or 2000, I guess it was. I was early in the Scrum community, did a lot of Scrum training in 2000. My company at one time was one of the biggest Scrum training companies around. We had 3 certified trainers. Those were the days. But it hasn't significantly changed. Now, people may disagree, but it's still based on iterations, time box planning. It's still based on having cross-functional teams. It's still based on, it's a framework within which you figure out what to do. And I don't see them being what I would call particularly self-reflective. And I think that's an important missing thing, okay? And here's another example, sometimes almost defensive. In 2007, I actually suggested that Scrum could be improved by thinking of it as a partial implementation of Lean, and the result was I was banned from the Scrum development group for saying that. Ken and Jeff both trotted out that no, that's not the case. Jeff did admit Lean was useful, but he said Scrum was definitely not based on it. And yes, I know if you look at his book, Developing Software in Half the Time or whatever that is exactly, he changed his tune a few months later, apparently. Finally acknowledged in the latest Scrum guide that it is based on Lean, but I would suggest not. The point is we have to start looking at the whole Agile space in a different way. And I don't think we're very scientific. I don't think we're very engineering. And part of the reason for this, and this is not directed to those people, those two I mentioned, but really in general, this is the truth. It's hard to get a man to understand something when his salary depends upon his not understanding it. This is rampant in the world and in our industry in particular. And I think we need to have the courage to overcome it. Okay. I suggest we need to reclaim Agile. Again, the Agile Manifesto is not the territory, it's the map. Scrum, SAFe are not the territory. They're maps. And there's a lot of good stuff in them. I don't mean to berate them. There's lots of good stuff in both. Actually, I was a SAFe trainer. I was the first SAFe trainer outside of SCI. I was a gold partner. I was a contributor. And I did that because there was a lot of good stuff there that at the time, 2011, 2012, other people weren't talking about. But it's grown in a complicated way, and it's very complex now. So I left there years ago because I couldn't get change. So to me, if you're teaching Agile, you need to be Agile. And this is a very interesting quote. This is actually the first principle from the fifth discipline, which is today's problems come from yesterday's solutions. And I think some of it is this quote by Bucky Fuller. Okay. I'm going to let you read it. I've heard that's better if people read it instead of me reading. So I'll give you a few seconds to read this yourself. So I would agree with Fuller that we're still clinging to a great many things that do work, but there are better ways. And the question is, how do we find these better ways? And that's what I'm looking for. And we have to recognize, not only is Upton Sinclair's quote about it's difficult to get people to understand things when their salary depends on them not understanding it. We see this a lot. No, misspelled Arthur's, sorry. All truth passes through three stages. First, it is ridiculed. Second, it is violently opposed. Third, it is accepted as being self-evident. Actually, that's what happened with Lean. You know, it was ridiculed when I said Scrum is a manifestation of Lean or a partial manifestation of Lean. And now it's, well, duh, yeah, except we want to look at that. Okay, so I want to talk about success and stakeholders, and I want to recognize Tom Gilbert in this talk. And this book in particular, he's written so much, it's hard to actually say what's the particular thing to read of Tom. Tom has been sometimes called the grandfather of Agile. He was kind of a mentor to many of the people who were at the Agile Manifesto who wrote it. And actually, he's not a big fan, ironically, of how it's been written. I really think Tom is one of the more brilliant people on the planet. And if you had a ratio of brilliance to being known, he's probably the most brilliant unknown guy out there. He's written a lot, and you can get a lot of his small ebooks. Very inexpensive. This is a great book. It's a bit big. It's published 17 years ago, I think. But his approach is very brilliant, and it's not mechanistic. He talked, and he's got hands-on experience. He's one of these uh, people who has written a lot, but has written a lot from experience, and he walks his talk. I talk to him a couple times a week. He and I are buds. Uh, we haven't actually worked together, but we've known each other for, I guess, now about 6 months. And somehow he's taken a liking to me, and I just love learning all I can from him. So competitive engineering is a good recommendation. This idea of focusing on success and stakeholders sounds obvious, but it wasn't something I did a lot until I really kind of got a hold of him in working on this. So that's an important thing, and I just want to acknowledge that. So why focus on success? Now, this seems like a funny thing to say. Well, duh, what else would I focus on? Well, you don't actually hear people talking about this much. You hear a lot about value, but value doesn't necessarily mean success. It may be value that's not the right value. So I think what you want to do is look, and this is kind of what Tom talks about, is what does the success mean? And these 4 levels I've got are maybe more personal or success engineering's uh, take on it. I actually believe we do talk about like value to the customers, no question, but it really needs to be done within the context of value to the employees, like respect the employees, give them a good working environment, have it be sustainable. This is all very important. And of course, the organization has to make money, has to stay in business. So there's success for the organization. And you may or may not agree, but actually, I believe companies need to add value to society. Uh, you know, and that when we look at success, we want to look at all of these aspects of it. How am I serving our customers? How are our employees being taken care of and being given great working environments? That implies a lot of things beside the respect. How does the organization win from this, and how does society benefit from the company being there? On a personal note, I will share something. Um, in the mid to late 90s, I was listening to a lot of tapes by Earl Nightingale, and he said something that was very impactful for me. Earl Nightingale has sometimes been called the father of the personal development group. He passed away years ago. I don't know when exactly, but um, I used to listen to a lot of his tapes. And one thing he said money was a reflection of the value you're contributing to society. Now, obviously, that's not totally true because drug dealers make a lot of money and things. But what I took it to mean is that you go after the value you go after value. You go after how do you improve value for people, and then assume you get benefit. And I think that's really the mantra that we want to come from. So I think that's why it's important to think about these. But you then have to ask, okay, we've got these 4 levels: customers, employees, organization, society. Well, who are your stakeholders? Now, the stakeholders are different. Even customers, like think of a pizza company. It's an example we use in the Discipline Agile Value Stream Consultant Workshop. A pizza company, you got a lot of stakeholders. You got the owner of the franchise, if it's franchise. You got the owner of the big company, franchised or not. You've got the people working at the pizza place. You got the customer there who's ordering the pizza. You got the delivery person. In a sense, you've even got DoorDash now if they're delivering the pizzas for you. There are a lot of stakeholders, and these are not personas per se. These are different people because a stakeholder can have multiple. You can have different personas in a stakeholder. The executives. Who are these others? We need to consider this. So here's the question that you need to think about. If you don't know who you're adding value, how do you for? If you don't know who you're adding value for, how can you know what value to add? See, this is what's the word I'm looking for? This is kind of something that's just happened because of the focus of the Manifesto for Agile Software Development that was about the team and about the customer. We've lost a lot of this. What are all the stakeholders out there that are beyond the team, beyond the customer? And we need to spread it out. Agile is no longer a team-centric thing, but back in 99, 2000, 2001, actually until about 2005 or 6, it was definitely just a team method. And that's not where it's being used. We've got to expand our thinking. Okay. So now do you even know what's of value? Do you have clarity on what's valuable? Okay, how do you manage this? Also, do you have clarity on how far off you can be? In other words, uh, if I'm trying to go for a certain amount, how far from that can I still be successful? In other words, if I want to create a certain number of uh, features or have a product that has a certain capability, how close to that can I get and still be successful? These are questions we have to ask. How are we managing our risks? What do your approaches tell you about the risks of their adoption? See, this is something that's to me, it seems kind of obvious, but it's not done. In other words, what's the risk of say, Scrum adoption? What's the risk of a safe adoption? And I don't mean to be picking on them particularly. They're just the 2 big gorillas, so I'm going to talk about them. What would be the risk of doing a DA adoption, Discipline Agile? What would the risk be of doing a less adoption? Except for Discipline Agile, where we do talk about the risk, or the success engineering is what we call amplios. You may have noticed that amplio stands for improve in Latin. We explicitly talk about the risk of adoption. Well, what if you don't have that? Then you're taking something and you're not looking at the risk. So stakeholders, value, risks, understanding constraints for it to be considered successful, understanding what the risks are, I think I'm talking about things that aren't talked about a lot. And if you stop and think about this for a little bit, that's actually kind of amazing. I mean, how can we not be talking about these things? I think it's really stunning. I really do. Okay, so let's get into what's engineering, because a lot of people, I think, misunderstand what engineering is. A lot of people will look at this building an overpass and think, oh, that's engineering. Yeah, civil engineering, building overpasses, building roads. Engineering is very simple, very straightforward. I consider this, yeah, it is civil engineering. Yes, that's true. But it's more to me like manufacturing outdoors. I've done it. I've done it a million times. I've got books I go to. It's pretty mechanistic. Yeah, there's a little bit of design. Yes, I have to put it in the context of the ground I'm doing. There are issues. Yeah, and every now and then something goes wrong, but that's not interesting engineering to me. And then, okay, this is a little more interesting. I have to deal, I'm in an enclosed space. I've got to figure out how to get the cars from one place to the other. So I need more design, I need more architecture. Uh, but this is still not the really interesting engineering. This is still just now a big manufacturing project outdoors. Okay. Excuse me. I want to start with this as a context. I want to look at engineering, science, and religion as a background. It's a little funny. So I love this quote by Albert Einstein: scientists investigate that which already is. Engineers create that which has never been. Now, what he means by this is science. We look at what's happened and we come up with theories to explain it. And yes, part of the scientific method is running experiments to validate or invalidate. But science is about the model we have created to understand what we know from experience. Okay. And engineering, though, and this is a fabulous book, Discussion of the Method, Conducting the Engineer's Approach to Problem Solving by Billy Cohn. He talks about the engineering method as a strategy for causing the best change in a poorly understood situation within the available resources. And this is very important uh, to recognize. See, engineering in a funny way goes beyond science. It also lags science. In other words, if you look back here and see something like this, yeah, we've done this. But it also builds things that have never been done before. And there's a certain risk with that, but there's a certain beauty with that. See, this is more interesting. How do you span the San Francisco Bay? This, of course, the Golden Gate Bridge. When this was done, this was an interesting bridge. There's also sometimes more art. This is Antonio Gaudi's creations, Spanish architect. In fact, he built some things. In fact, this building on the left there, he built that. He designed that rather before he had the technology to get it done. That was kind of interesting. He said, "Well, look, I'm going to design this, and here's where I'm short of the materials I have. I can't get this going yet." So but he knew there would be advances. So these things, some of the things that were built here in engineering had never been done before. And he was cutting edge. And then after they were done, we had a better understanding of things. We've seen this a lot with bridges. Bridge design has extended and improved. Also, when you're leading edge, though, there's a potential problem. Here's a famous one. This is the Tacoma Narrows Bridge. It's near the city of Tacoma in Washington. They call it the Tacoma Narrows because you can see that you can see I'm on one side of land and then there's the other side of land, and that gap where the river is, it's actually part of the Puget Sound. That's called the Tacoma Narrows. Uh, and as you might imagine, wind comes through there, and the wind didn't blow it down. And it's actually a lot more complicated as to what happened than mere harmonics or things like that. There were a couple of failures uh, on the bridge, minor failures. And these minor failures ended up the bridge oscillating and then collapsing. Now, if you've never seen that, go ahead, Google Tacoma Narrows Bridge, and you'll get an amazing video. And it's a perfect example of something because the designer actually was warned there was a problem. He was warned that when you had a narrow bed like that, that's 2 lanes wide, when you had a narrow bed like that, over a long span, which it was, that you could get some problems with the wind. And he had taken some steps he thought was sufficient. But see, there wasn't science here. There wasn't an understanding of wind and velocity and harmonics and the width of a road versus the length of the road versus the height of the road versus the stiffening that was needed. So sometimes when you go beyond something that's been done before, you get adverse situations. As some people like to call it, oh, we had an anomaly on the Tacoma Narrows Bridge here. Okay, so There's another anomaly, the Titanic, obviously. And the Titanic is a very interesting disaster because when you study it, and I have, I've read several books on it. I'm kind of had been. I feel like I've studied it so much. I'm not so fascinated with the story as much as I am fascinated, though, with how it happened. Uh, it was a combination of about 8 factors. It wasn't simply the Titanic hit an iceberg and they didn't have enough lifeboats. There was all sorts of things. The steel was bad. It had sulfur in it, high sulfur content steel in cold water is brittle. The rivets were bad. The didn't have the binoculars on the ship that they normally have because they were in the harbor master's safe. Why they took them off the ship and didn't keep them in the ship's safe, I don't know. But they didn't have that. It was a calm night, no wind and no moon, which basically meant you couldn't see things very well. Icebergs were easier to see in wavy water because the waves would go against the ice and you would see it. No moon meant no light. Um, they knew the icebergs were out there. They actually quickened the pace because they wanted to get to make a crossing fast. And there was a belief by some people that when you're in an iceberg infested area, you go through it faster because you get out of it quicker. I'm not sure that logic holds true. The iceberg had to grace, excuse me, the ship had to grace the iceberg. If it had rammed it head on, it would have crushed the front. But the bulkheads would have held because the bulkheads, only the first one or two would have held. It was the rupture of of like 3 or 4 bulkheads that caused a problem. By the way, the size of the hole in the ship was about the size of a refrigerator door. So you get all these factors and you come to the conclusion that the Titanic sank with insufficient lifeboats for one reason. It was held to be unsinkable. They did so many things that made no sense whatsoever, except that it was unsinkable so we can get away with these things. Oh, yeah, then I forgot the California, the ship, that didn't respond to the Titanic's distress that could have saved a lot of the people, didn't respond for some weird atmospheric condition that made the radio not work well. I mean, this just amazing number of factors. Okay, so this is also what happens when you go beyond the state of the art. Okay, this is the point of this whole dialogue here, and something we don't do. See, engineers don't just do post-mortem of their project. They don't just look at why the Titanic sank. They don't just look at what happened with the Tacoma Narrows Bridge. They don't just look at what happened with 3 Mile Island, which I'm going to talk about in a few minutes too. They look at what are their methods? What caused this to happen? What were we not looking at? See, and it's not about, oh, we're going to look at everything because things are too complicated now, too complex now. We don't tend to do this. Framework developers typically defend their methods by explaining people use them. Oh, yeah, well, they're not doing Scrum. Oh, yeah, well, if they did this. Oh, well, if you're not committed, then you should expect this. See, to me, this is not acceptable. If you put together a framework, and I've done this, you got to take responsibility for it, and I do. And that doesn't mean it's going to work all the time, but you got to see why and how do you improve it. And this is very important. And you might start get a sense of now those quotes I made about it's hard to get a man to understand something when his salary depends upon his not understanding. This is very scary. Your livelihood is on the basis. You don't want to talk about how you messed up. Okay. But I suggest we don't have to be at the effect of what we can't predict. Okay. Because this is the other thing. In fact, I think there's kind of a synergism here. I don't know, except what's a synergism when it actually makes things worse? Okay, so there are a lot of complexity theorists in the agile space that have been embraced for saying, well, we can't predict. And well, yeah, if you don't have a model of things, you can't predict. And I'm not saying you could predict everything because you can't. And I'll talk about that. I think in the agile space, it's important to understand cause and effect present in complicated and complex systems. It's very important to do that. And that even when you don't have full predictability, it's really important to have predictability of what you can predict. See, there's a lot of stuff we can predict, and we can't throw the baby out with the bathwater, so to speak, by saying, well, we can't predict the whole thing. Okay. Most of the waste in knowledge work. Okay. And I've been studying this I've been in knowledge work as a consultant since, I guess, well, actually for a long time, but I guess it kind of started when I stopped building systems and moved, I started building systems actually in college through about 96, 97. And when I became a coach in software development because I was a heavy developer uh, up until around 2000, and then I shifted into coaching developers, and then I shifted into team and enterprise uh, methods. And I would suggest, in 2 decades of observing literally hundreds of cases and talking to dozens and dozens of consultants, that most of the waste in knowledge work can be attributed to errors that go undetected that create huge amounts of waste than because of complexity. Now, complexity causes a lot of this. So there's more to be gained by increasing the rate of feedback than there is in trying to understand the nature of your development system. So this is part of what I'm going to talk about in the engineering approach and what we do, but I'm trying to give the background as to why this is so important. Okay. Our problem is not complexity. Well, it is a problem, but we repeatedly violate understood laws of nature. And if you're not dealing with nonlinearity of coupling events, some little mistake, I misunderstood this big problem later, that's actually going to be a lot bigger. So if we look at this work, let's say we make this graph, work's being done consistent with the laws of knowledge work. By that I mean flow, lean theory, constraints. They do a pretty good job. There are other theories. These pretty much cover it. And I'm going to give a quick overview of them too for the uninitiated. The amount of challenge due to complexity. Well, most people are down on the left. They're not consistent with the laws of knowledge work, and the amount of challenge due to complexity is low. It's really because their work's not consistent. And that as we get more consistent, complexity becomes a bigger problem because we've solved this other problem that's a bit easier. Most companies work in a way very inconsistent with the natural laws, as I call them, of knowledge work. And when I say the natural laws, I mean, I didn't make them. They're just the way they are. I can understand gravity, but I didn't make gravity. I can talk about gravity. I can talk about these. And that's what I'm referring to here. Okay, and I would suggest that there's more known that we don't pay attention to than the unknown that complexity hides from us. So this is the idea. Let's get what we can get that's straightforward. We can know, there's a lot of stuff known about the laws of knowledge work. Let's learn that before we worry about what complexity is causing problems for. Okay, so let's talk about this, the science of knowledge work. By the way, I wouldn't mind in the chat if people put in some feedback for me. Is this too abstract? Is just waiting till I get to the good stuff? I've been called abstract before. So I wouldn't mind that. I'm looking at the chat and I wouldn't mind that feedback. I'm probably going to continue with this anyway, but it'd be nice to know. Anyway, I want to introduce a term that I created, but you know. I call it value stream impedance. And what I mean by this is what's impeding us. Impedance is a resistant term. I got a master's from MIT, so I'm part electrical engineer, I guess. And what we want to see is what's stopping us from success. What's stopping us from delivering value? See, I'm starting to create a theory that might help us go forward. And I suggest we already know a lot of this stuff. We just need to make it explicit. Again, I mean, one of the most kind of great things I did and one of the most dumb things I did was in 84, 85 when I built this system and I used automated acceptance testing because I was in trouble. I was breaking the system all the time, but the automated testing worked great. And then I didn't use it again. I hate to say this. This is embarrassing. I didn't use it again for 15 years. Why? Because I had just solved the problem with it at the time. I hadn't stepped back and I was not thinking of process in those days like that to reflect on things. And when I saw XP, I said, "Oh man, all these one-offs, they make a system." It was like an epiphany for me. So what I realized, thinking about this later, I'm not going to be so smart and so stupid all on the same thing, was that making things explicit is very, very critical. Okay, so you know this. So here's a question. I'm going to give you two questions. When have you gone into a place and knew it was messed up? Like, oh man, how did these guys get any work done? But sometimes you got into a place and knew it was effective. Okay. The question is, what were you looking at? See, this is what I'm talking about. This is what I meant by value stream impedance. Like some of the things are, well, they're multitasking a lot. Oh, they're working on too many things. Oh, they've got too much workload. Oh, they're planning way beyond what they could possibly know. Oh, management is demanding things of them. You see what I mean? This is stuff you know. It's worth writing this down. it's worth being clear about it. Now what we're doing is we're creating a little bit of science. We're saying these things cause these problems. Then you could ask, how do we solve them? Okay. So I'm going to give, like in 5 minutes, the essence of flow, lean theory of constraints. They're all consistent with each other. I use all three of them. They each contribute a different perspective, which is why I like to use them all. And I don't really worry about where does flow end and TOC begin. They're also interrelated. That's not worth the conversation, but learning the essence of them is. In flow, you attend to the value stream from concept to consumption, like how does work get done. In lean, it's based on systems thinking, Deming as well, remove delays, you've heard just in time, build quality in, stop the line, focus on learning, add more value to your customers. By the way, a lot of people talk about lean as focused on eliminating waste, and I'd suggest underneath that is a more important term that they are focused on learning. Of course, maybe learning how to eliminate waste. It's actually about learning how to create more value for the customer with less waste. And theory of constraints is attend to the constraint in the system. Now I'm going to go through these each quickly, but I want you to see that there's some lessons here. And one of the things you should be doing while I'm speaking here is looking at if you see evidence that backs up my assertions about what these three things are saying. Don't worry about if it's flow or lean or theory of constraints. But if I make a comment that lean is about this and it's useful and you don't agree, or flow is useful, you don't agree, that'd be a good question to ask. Or you don't see how, that would be a good question to ask. And So what flow says is attend to the value stream, like all the steps, avoid delays between the steps. You've got to manage your queues. There's a lot of where work in process managing that comes in. Lower your cost of delay. What's the cost of something being delayed, basically. Work on full value streams when possible. In other words, not just the team part, because that'll get you a product. It may not go out the door. That's why DevOps is so good. Well, one of several reasons. One reason is it's just really great because it lets devs and ops people work together, but it also expands us out of the team. It expands out, oh, we got the product built. We have no clue how to get it to the customer. So that expansion is good. Okay, so there's more in flow than that, but that's some of it. And that reference, sorry, I should have mentioned that. This is a fabulous book, Don Reinertson, Principles of Product Development Flow, Second Generation Lean Product Development. If you wonder why I put flow before lean, this is why, because actually I think flow goes beyond lean. Lean, by the way, though, is not about Toyota anymore, okay? In 2009, I was the keynote speaker at a conference David Anderson and I put together called Lean Kanban, Miami Lean Kanban. And this was kind of the coming out party for Lean Kanban. And my talk was actually Lean Beyond Toyota. And because I'd been talking to Don Reinertson, I realized Lean actually stood on its own. And this was actually not usually precognitive, but I was worried, what if Toyota really messes up big time? And then people say, oh, lean's not good. And this was months before the Toyota brake problem, which is another interesting story. But the point is flow, I think, is actually one of the overall views of things. Now, the lean strategy is a really good book. Michael Ballet, I've also friends with him. We've never worked together, but what I really learned when I read the lean strategy is lean is really about education. And this was in Taiichi Ohno's Toyota production system, which a lot of people look at the explanation of lean. My point for that little digression is that lean is not just about manufacturing. Lean is also about product development, about software. If you go under the practices of lean and look at the principles and the laws that it exposes, like delays cause waste, like you need to keep your work and workflow visible, that you see that these things are just laws that are out there and consistent with flow. But what really Toyota was trying to do after World War II, and what Ono was doing with the Toyota production system, was educating people on how to be better, eliminate delays, more value. And the lean strategy doesn't talk about Toyota. It talks about a lot of places where lean has been implemented, and it gets very clear there. So it's on continuous learning, not just at the end of a sprint. This is something that you should do. I threw that in because if you're doing Scrum, then you should be looking at how do I learn every day, not just with a daily stand up of like, how are things going, but how do I change my approach literally every day, like micro retrospections whenever a problem comes up. It's is a flow system. It's not necessarily one piece flow, because there could be transaction costs and things. That's gotten a phrase, leans about one piece flow. No, they do that in Toyota and building things. That's not necessarily everywhere. You want to recognize delays cause waste. It's a system thinking. Challenges come more due to the system than to individuals. That's why there's this notion of stop the line. If something goes wrong and it's caused by the system, then we better stop the line so we don't keep producing it. Now notice, as I've been talking about flow, and as I've been talking about lean, I'm projecting theories. This is science. This is stuff we've learned. You can disagree with it. You can provide evidence. You can support it. You can provide evidence. I suggest you look at your own experience. See, this is one of the things I always, when I work with clients, I always say, look, you guys know a lot. You may not know lean, you may not know flow, but you've been doing work for a long time. Use your experience to validate whether something somebody's telling you to do is right or not. See, we take frameworks as they are. I'm suggesting take frameworks as an hypothesis for that it's going to work better. And then you use your experience to determine that. And if that can't be demonstrated to you, then don't work on faith. Consultants need to explain things to people in a way they understand. Okay. Now, not last but not least, I mean, theory constraints is a very brilliant thing here. And the goal is where this was espoused. Actually, there's another book called The Choice of his that I'll refer to in a few minutes. But basically, in a nutshell, and I'm not the expert on theory constraints, as a variety of other people I know are. If you want to learn more about theory constraints, I would suggest Steve Tendon's TameFlow. He's knows more about TOC than anybody I know, but there are a bunch of others who are quite good about it. Look at the constraint, maximize the work done at the constraint. In other words, make it more efficient. Don't worry about slowing down non-constraining things because it won't slow down the value. You're looking at the entire system. Repeat as you need to. And just a side observation that's consistent with all these, small things are better. Often reducing batch size is all it takes to bring a system back into control. Okay. So just put them all together as kind of a summary. You got the essence of flow, lean, TOC, 3 things I'll just let you read. So what I've been doing is putting forth what I would say is the science of knowledge work. Because if you do flow, lean, and theory constraints, you'll do better. Now, if you don't do them, you'll do worse. Now, it doesn't mean that if I follow them, I'll get immediate improvement because there might be multiple things going on because we're in complex systems. So let's look at that. How do we deal with complexity? And there are 2 attitudes out there, at least. Okay, first of all, I want to be very clear. This talk is about dealing with complexity in knowledge work. It is not about dealing with complexity out in the world. I'm not talking about black swan events, like somebody comes up with a new product that revolutionizes things, or the pandemic that we're all familiar with too much. I'm not talking about that kind of stuff. You could deal with, well, when those things happen, how do I respond to them? Well, okay, be agile, be able to shift. That's great. So I'm talking about the complexity inside an organization, okay? And I want to point out that our attitude about a problem is often a problem, okay? And this is from The Choice, again, one of my favorite books. It's actually by his daughter, but it's really him. She goes through explaining past conversations between the two of them. It's extremely well written. This book is probably one of the top 5 books I've read that's had an impact on me a lot because he also talks a lot about critical thinking. You will think clearer after you read this book. But I love this observation. The hardest thing to do is to struggle to find an answer to a problem when we believe that there is a high chance that it doesn't have an answer. It is so easy to give up. That's why Father recommends starting with a conviction that a better solution exists for sure. I think this is the attitude to take. And yes, I know I'm dealing with things where I can't see everything. Oh, okay, good. Then what's the attitude to take about getting an answer when you know you can't see everything? How do you prepare for that? How do you prepare for the unknown? See, I'm not going to give up, though. This is an attitude thing. A lot of people, in my mind, have given up. They said, oh, it's complex. We can't figure it out. We just have to try things. We have to run experiments. And I'm saying, no, there's lots that's known. Okay. And this is a observation by Steve Covey. The way we look at the problem is often the problem. Okay. And I love this by Edgar Sheen. We do not think and talk about what we see. We see what we're able to think and talk about. So how we frame things is extremely important. again, throughout this talk, I'm suggesting we frame things through an engineering and scientific approach in an attempt to create success for our stakeholders. I think that's a very important framing. Okay. Also, I love this by Jerry Sternum. It's easier to act your way into a new way of thinking than think your way into a new way of acting. Now, if you read this, and if you agree with it, then it makes kind of silly that people say, oh, well, you need an agile mindset. Wait a moment. Wait a moment. You're telling me to adopt this, I need an agile mindset. Well, that's not consistent with this right here. In other words, how does the way you're working, how does the way you're learning how to do something, how can I act my way into it, not think my way into it? See, this says you're going to think your way into it. And that's consistent with saying, oh, you need the agile mindset. And this is one of the reasons I really dislike this idea. Oh, yeah, you got to be agile to do agile. I'm saying, no. I mean, well, it'd be great. But probably you need to learn how to work to get you more agile acting, and then you'll get more agile being. Okay, this is this mindset I'm talking about. Okay, oh, here's the choice. So Goldratt had a different attitude on what complexity was. And the first and most profound obstacle, this is my favorite quote, is that people believe reality is complex, and therefore they are looking for sophisticated explanations for complicated solutions. It's this attitude about, oh, we got to get this complex solution. Now, he actually acknowledges later, of course, that the world is complex, but it's that if you grasp it as complex, when it's simple, okay, so you accept real life situation no matter how complex it looks. But once you really understand it, it's not that complex. And this is important to recognize. So inherent simplicity, which I use different terms, but this is where I've been trying to figure this out for like literally 15 years before I read this book. Like there's sense here, but I can't quite figure it out. And year after year, because I started this endeavor around 2005, I couldn't get it. And a couple of years ago, I read his book. I said, oh my goodness, I kept getting closer and closer. But once I read this book, I understood that what are the few things that is, and this comes from Newton, Isaac Newton, yeah. Nature simple, harmonious with itself. Now that may sound a little simplistic, but what it means is that the things that cause problems or the things that work together, there're not that many of them. They're coherent, they're in harmony. If you break one, it breaks others. If you do one, it helps others. Now, if you're a developer, this is just a side to developers. You've seen this with coupling, cohesion, encapsulation, that as you do one of those, it helps the others. It's that. He's also saying this is in process. And if we dive deep enough, we'll see that at the base, there are just a few causes and effects that are driving the system. And I'm going to show you what I think these are. Now, it's not my set's right. Okay, and this is the caveat. It doesn't claim reality is not overwhelmingly complex. Of course it is. But that there's a way to realize that from another important aspect, it's simple. So complexity makes it difficult to see what's going on. Inherent simplicity gives us a way to look at this complex system. And I think this is extremely valuable. So he's saying that that reality, any part of reality, is governed by a few elements. So what are those elements? That's the question. And I'm going to present them to you in just a few minutes, what I think for knowledge work, okay? But here's the other thing. If I'm not really sure that a second effect does exist, I might stay in the box. It's always safer to stay within comfortable boundaries of a box and jump into the unknown. Since the other effect is not within that box, I won't find it, and it'll keep searching, basically have circular logic. Okay. A comfort zone. This is a very important observation. A comfort zone has less to do with control and more to do with knowledge. We're always blaming managers, saying, oh, they want to command and control. I'd suggest they want to understand. Well, they don't want to say that, though, because they're supposed to be the smartest people in the room and they're supposed to understand. Not that that's true, but that's what we've taught ourselves, or they've conditioned to think of themselves very often. So understanding is really critical here. Okay. And I just came up with this. To me, inherent simplicity is to complexity like night vision goggles are to darkness. There is complexity. There is darkness, but night vision goggles allow you to see in it. So I just like that. Now, there's one more aspect to this, and then we'll get into inherent simplicity in particular. And I want to look at these 5 things, or not 5 things, sorry. The system thinking is this idea that you have all these components, all these pieces. And if you look at an airplane and you ask, what makes it fly? It's not the wings, it's not the body, it's not the control surfaces, it's not the pilot, it's all of them together. In fact, if you improve one of them, it may make it unflyable. And in Russ Akoff's, if you Google what if Russ Akoff did a TED Talk, Uh, he talks about if you get the best parts of the best cars, put them together, you have a pile of junk. Systems are based on the relationship between the pieces. This is, by the way, what makes complex systems complex, of course, is that there are all these relationships between everything. And it also makes, like, again, Deming, one of the foundational thinkers of all this, is you recognize that you have to manage your system because otherwise the components will manage themselves, becoming becoming you know, basically local autonomous. Now I should be careful what I said. You don't want to manage the individual pieces. You don't want to do micromanagement. You do want teams to manage themselves. You do want autonomous teams. You do want to have self-managing teams, but within the context of the system. So you manage the system. You don't manage the pieces. This is a big shift, is we're not managing individuals, we're not managing teams, but we are managing how all these things relate to each other. We're managing those relationships between things, and that's important. Okay. So what we want to do is these 5 steps. This is kind of the science and engineering approach. I'm saying make things simpler when possible, use inherent simplicity to see how to look at things, improve on the complicated. There's stuff that has cause and effect we can see. How do we deal with the side effects of complexity, and we tend to failure recovery? This is basically the approach that success engineering takes with working with large scales. How do you do all this? What's the framework you would use to get this done? Okay, so I'm going to go through these. First one quickly, second one's long. Well, some things are easy to just better communication, make your workflow visible, make the work itself visible. These are pretty straightforward things. How do you do things? This isn't just transparency, like make the work visible, but why are people working the way they're working? That's very important. Glossary of terms is very simple practice. I was just trying to give it as an illustration. There are some things you can do, and we abandon it. Okay, now here's the big slide. I meant to have this where I could expand it, but then I forgot to put that in. Please don't read it all. It's there for your enjoyment later. And I'm going to put a LinkedIn post after this too that'll talk about some references, including this slide. What I really want you to look at is this column here. Okay, I don't have time to go through all this. I could spend an hour or two, but I just put it up there. But let's go through these factors. And if you want to read deeper, and you can. So what I have found when I go into organizations, so I've been doing consulting at organizations, I guess, well, actually for a very, very long time, but lean agile consulting, flow and all that for about 17 years now. And what I have come up with is by studying what I did, studying what a lot of other good consultants did, by talking to a lot of people who weren't so good did. You know, I've been in conferences for years and years and years and literally consolidated from hundreds of examples and case studies. I have learned that if I look at 8 things, I can tell how good the value stream is being done, how well the work's being done. Now there are other factors to consider, culture, management, things like that. But I'm not talking about that. This is just the mechanistic point of view of what to look at. And these other things like management, culture, a variety of things are other factors I tend to. But how is the work going? Okay. So first of all, are they doing value stream management? Are they attending to the whole value stream from concept to cash? Or like XP's first thing, the C3 project, no, they were only attending to a small part of it. They were only attending to the team development. They weren't attending to the product management. They weren't attending to how it would be deployed. They weren't attending to the culture of the things. So that's an important piece. Are you working on small items of high value? Well, here's what's interesting. Most companies don't even have the concept they need to do this. So we talk about MVPs, you know, minimum viable products. That's when you have a new product. That's when you have, if you're at scale, that's when you have multiple teams working on it. You know, excuse me, that's when you have typically one team working on it. What do you do when you have multiple teams working on it? See, MVPs have been somewhat bastardized in my mind by SAFe. MVPs are intended for a small team building a new product, discovering it, quick cycles, not 3-month cycles. Yeah, I know you can force fit it in there, but a team working on something new and you know who's doing it. What about large companies, multiple teams, multiple impacts? So you need the concept of the minimum business increment. I have that kind of in the guidance. You can Google that or go to processmentors.com and find it. That's a partner company of ours, and they've got a nice write-up on it. Or just minimum business increments. PMI's got some nice write-ups on it. It's part of the discipline Agile Value Stream Consultant. But what's of value? See, epics, not all of that's of value. Features, that's usually too small to get delivered? What's the concept of something I'm building across the organization? Do I have that? Okay. What's my workflow quality? Do I have large queues? How am I task switching? Are there delays? Are there handbacks when work goes forward and then comes back? Is work visible? Is the workflow visible? How I'm working visible? This was a big controversial thing back in 2009. David Anderson and I talked about you wanted explicit workflow policies, and Ken and Jeff blasted us for that, saying, no, then people are going to follow these. And I'm like, no, they're not following them. It's just an explicit agreement. How are people working together? If you don't have that explicit agreement on how people are working together, then you're going to have confusion. You're going to have problems. So I look to see how that is. Are you getting quick feedback? This is extremely important. We'll see why in another few minutes. What's the efficient value creation structure? Scrum says cross-functional teams. Well, those are great. What if you can't get them? What if it's painful to get them? What if they're actually not desirable? Because sometimes they're not. I've been in many situations like that. There are lots of different ways to organize people, organize the talent, as some people call it. How are value streams intertwined? You have some people in multiple value streams as a symptom of that. What's the quality of your product and the product quality and architecture? I'm suggesting, and you should take this, and like I say, this is available. I'll give a reference on a LinkedIn post. So follow me on LinkedIn, Al Shalloway. It's real easy to find me, Alan Shalloway. These 8 things give you incredible insights in complex systems. Okay. And this is a summary, I guess, as an extra slide. So I'm just going to go past that. Okay. How do we improve on the complicated? I'm suggesting there is cause and effect, but it's embedded in a complex system. It's kind of like a driver driving backwards on the wrong side of the road using the rearview mirror. That's complicated. It'll look complex to that person, but the driving is actually complicated, but it makes the system look complex because they're doing it badly. So we have multiple failures have one symptom. So you might fix something and it doesn't seem to improve anything. So we got to get clear that sometimes fixing something when many things are broken may not get us immediate resolution, but should get us learning. So that's important. You can't separate those actions that have cause and effect from complex adaptive system. It's all together. This is the whole thing about systems. You cannot break them down into, oh, this part's complicated, this part's complex, this part's, no. It's all, every aspect is present almost everywhere. Okay, but if you make things work better, the chaos and the complexity gets better. Okay, now here's some specific advice on this, and you may or may not recognize that. That is the reactor building cooling tower schematic of 3 Mile Island. And this is a great book if you like reading anecdotal stories that kind of tell you how people mess up. Though I do it not to make me feel better about myself, like, oh, I'm smarter than those guys. It's actually the opposite. It's like, no, I'm not smarter than those guys. That I would probably do the same. So it's kind of like analyzing why or how they got into errors. And in fact, I should have a reference here in this book when he talks about 3 Mile Island. He's actually uh, giving a summary. I think it's by Perot, and I should have put that reference in. I just bought his book based on Perot's book based on this idea of the summary that was in here, and it's actually about what causes complex systems to fail. And it's not so much the huge complexity that's present as much as the relationships between things. I forget the title, but I'll put that in the LinkedIn post too. Anyway, what's interesting about 3 Mile Island was, yes, it was normal accidents living with high risk technologies, Charles Perot. And what happened was actually a very small failure that caused that something happened. The vent opened, let water out. The vent didn't close, and then the measuring systems failed. And the measuring systems are in one part of the building, and actually the temperature of the water level was in the cooling tower, not the cooling tower, but in the in the reactor building. You couldn't actually get things measuring some things there, so they did water levels kind of indirectly. But here's the bottom line. Some little thing went wrong. Different things were coupled to each other. There was no real visibility as what was going on. It took them hours to figure out what was going on. By that time, the reactor core had already melted down partially. And in Perot's work, that's quoted in Meltdown. So I like reading Meltdown, but Perot's, it's a whole book about, or a lot of book about this. What the observation was that in systems like this, when you have some little thing happen and things are coupled together and you don't have visibility, there's the potential of a big event. This is what's called a nonlinear or chaotic event. This is different from chaos. Chaos will often occur from lots of non-linear events, but it's this little thing happens, a big thing happens. Now consider in software or any product development, a small misunderstanding causes a wrong thing being built. A little bug causes big impacts. So the question becomes, if we pay attention to something where people say, well, this is a complex system and all this, well, it is complex. But what we're really having happen to us is we're being damaged by the inability to see what's happening and by the tight coupling that's taking place. So in our work, in knowledge work, what we want to do is create visibility. You create visibility via feedback. Oh, is that really what's going on? So quick feedback cycles, not 2-week feedback cycles. I'm talking about daily, even hourly. Think about test-driven development by minute for some. I can never get that quick, but I have used TDD, but I did it a little different. Not as effectively, but it suited me. So this is how we deal with side effects of complexity. We recognize we can't see, so we create feedback to show us, okay? There's also this notion of what's your plan if things go wrong, okay? Most people don't have such a plan, but you should presume they will. Okay, there's a good book called The Checklist Manifesto. I forget the guy's name, but if you Google his name on a TED Talk he did, he talks about this failure recovery. It's really brilliant stuff. Checklists are good because they stop you. That's another way to make easy improvements to complicated situations, because at least, well, I won't make this mistake, won't make that mistake, won't make that mistake. Okay, now I'm going to close with some new things we've done, and we'll still have a few minutes for Q&A for decision frameworks. Okay, this is a very important observation, and I've been saying this, but I love the way Deming puts it together. I'm a big Deming fan. You've probably figured that out already. Experience teaches nothing. In fact, there is no experience to record without theory. Without theory, there is no learning, and that is their downfall. People copy examples, and then they wonder, what is the trouble? They look at examples, and without theory, they learn nothing. This is that blend of engineering and science I'm talking about. Not just presume if you do these things. Like I know Scrum has its, values, and Agile has its values, and we have their principles and things. But what is the theory as to why that works? Why would that work? That's not explained. One of my books, if you're a techie, I wrote Design Patterns Explained, is an example of this. See, well, this was written ways back, but it's still, I think, almost the only book that talks about the theory underneath it all, which was, see, what I was interested in patterns. I loved them. I thought they were brilliant. But what I was interested in, not that they were good, but why they were good. So if you want to get more into that whole patterns theory, there's some work I've done explaining Timeless Way of Building by Chris Alexander. That's another brilliant book that talks about this underneath. So what we need is double loop learning, and this is woefully missing in the Agile space. So single loop learning is kind of simple. This is like the inspect and adapt. I'm expecting this, that happened, how do I adapt? Fix it. Okay, that's great. It's like a thermostat. Keep it between 70 and 75. If it goes above 75, cool it. If it goes below 70, heat it. That's single loop learning. And this comes from Chris Argyris. I think you have a reference in just a minute. Double loop learning is learning that results in a change of value, theory of use, as we want to change the theory underneath which we're doing things. In other words, like, why are we doing iterations? Maybe we need to have a thought about that. Maybe we should do something different. Double loop learning recognizes that the way a problem is defined and solved can be a source of the problem that we're facing, okay? And long thing, again, I'll put a link on the link in, but double loop learning in organizations by Chris Argyris brilliantly describes this. You can see this has been around for a long time. In other words, not how do we just do the method better, how do we improve the method? In other words, not what were the errors made that the Titanic sank, not just were the errors made in the whatever you name, fill in the disaster. What was our thinking that had those errors occur? Another good reference, if you're interested in this, is any of Petrosky's work. He's a brilliant engineer. That's where I kind of learned a lot of this stuff reading his books. Okay. So you might notice that, looks like I copied this a little wrong, but you get it. Plan, do, study, act, okay? Oh yeah, I have it. I just added correction, action. So that's the A right there. Okay, so inspect and adapt's not enough. What we want to do is as we plan or reset our objectives, this is what we're going to do. And then we do it, okay? And we need a statement of discovery, framework for execution. That's a note to myself. Sorry. Then we study what happened. We use all of this stuff we're doing, our model of understanding, this flow, this lean, this theory of constraints. And then we take corrective action, not just in what we're going to plan, but our model of understanding. This is what's part of the double loop learning. In other words, as we go through, we're continuously looking at how we're making decisions and how we're learning. We're not just saying, oh, follow Scrum and it'll work, or follow Safe and it'll work, follow this framework and it'll work. We're saying why? What would work better? And we're noticing how we've got double loop learning going on here. Okay, so I'm going to introduce this concept. It's not really new, it's just talking about it different. So for years and years, don't worry, I'll go through that quickly. So for years and years, I said, oh, well, what I have isn't the framework, because I really didn't like frameworks, because it seemed that people are always telling people to follow the framework when I wanted people to think for themselves because they're capable. And then I realized, Al, you're not speaking clearly. You have a framework. When you end up talking about what they should do or what they figure out what they should do, that's a framework, but it's just dynamic. It's something they figured out themselves. And then I realized there were two kinds of frameworks. There's a decision framework, which for most people is ad hoc. Oh, they just do it tacitly or something. I spent 17 years now figuring out what this is. This is what we talk about in the Discipline Agile Value Stream Consultant Workshop. This is what we talk about in my collaborative engagements. The DAVSC is more for individuals. The collaborative engagements I do is I'll go into a company and work with them on how to do things. And we'll figure out what their execution framework, SAFe and Scrum are execution frameworks. The people who made them in their mind had a decision framework, but it was more tacit. They don't explain it fully. They're just like, well, you can't figure this stuff out. I'm like, no, yeah, you can. It's not 100%. It's a set of heuristics, perhaps. So the idea is we use the decision framework to create the execution framework. You can actually start from scratch, like build it from ground zero. What I find more effective is, for at scale, mid-scale teams, have one of a few you can start with. Like I've got, I think, 4 team frameworks. Some looks like Scrum, some looks like Kanban in the middle example. Same thing with something looks like Safe, something looks a little more flexible. And what you do, the decision framework can be used to figure out how we're starting. And then we do our work. We have single loop learning. Are we executing well? We have double loop learning. Do we need to change, improve our decision framework? So here's the double loop learning on the decision framework, or we're using the decision framework to change our execution framework. And I think it's important that anything you do, you have this explicitly stated and this explicitly stated. And this is unfortunately rare in Agile. And to me, this is disrespectful. That's why I'm saying we want to get to the respectful part, which is people are smart enough to understand how to do this. And I think that's very, very important. Okay. When you have decision frameworks, you open up new possibilities. You don't have to just start with something somebody else prescribed. You don't have to just build it on your own. With a decision framework, you can start from several quick starts, tailor as you learn. This basically enables you to continue with learn from the way you start to continue learning. You can build something, but now it's at least less expensive because you can combine things. And second to last slide, uh, I always hear things are like simple to understand, difficult to master, or want to keep it simple. It's easy to use. Rather, it's simple, just use it. And I'm like, look, simple isn't what I'm looking for. I'm looking for understandability. The unicycle is very simple. I actually used to ride a unicycle. And it's very simple to understand. It's very difficult to master. A bike's a lot easier just as easy to understand, just a lot easier to master. And I love 27 speed bikes. Oh, well, I'm going to teach my wife how to use a bike. Well, I'm not going to give her a 27 speed bike. Oh, wait a minute, maybe I will. I'll give her a 27 speed bike, but I'll just set the gear at a good pace for her for how the road is. I won't tell her about the derailleurs. That's what changes the gears. I'll only tell her about the rear brake because that's a safe brake to use. And she'll think it's a cruiser, like one speed, one brake. Easy. A lot simpler than a unicycle. Oh, then she learns more about terrain, goes into different terrain. So I teach her the rear railer. Now she's got 9 gears. Then I might teach her the front brake so she can brake better. Now I'll teach her how to do the front derailleur. Now she's got a 27-speed bike. At all times, it was simple, easier to master. So we want understandability, not simple design. Okay, and I'm suggesting that when you have a simple but ineffective framework, you don't want to do that. You require filling in a lot of stuff. If you've got everything but it's not understandable, then it's complicated, it's hard to use. We want to be up here, don't go down here. Don't go to complicated and not effective. Okay, last slide. Just looking to the future. Value stream management is the future. You see this more and more. I actually, if you're interested in that, one of the things we came up with in the DAVSE, I used to use value streams all the time, like from 2005 till about 2018, 17. I found they started being too expensive to build. It just took too much time, couldn't get everybody involved. So what I was able to do though is come up with what I call the idealized value stream. It's something you can compare, and in literally a couple hours, you can go through what would take days of work. It's like a Pareto thing: 80% of the value to 20% of the cost. Decision frameworks, we already have them, but they're not widespread. Quick starts, we already have them, but they're not widespread. Componentized frameworks based on engineering and science, I believe, is coming. And that's the end of the formal talk. Now we have time for questions and the wrap up. So I'll hand it back to you.
Can you please elaborate a little about value versus success? What kind of value can attribute to the success?
That's a great question. So I'm suggesting we start with what does success mean, and in that, talk to the different stakeholders, see which ones are most important, because there will be conflict. Some people want something, and something will want something else, and you have to determine by talking to the stakeholders what value means to them. Now, this is usually when you have existing products and the stakeholders actually understand what they want. When you're doing innovation, it's a different process. And I didn't include this, but I'm going to write up something where the way you can discover what value is to stakeholders is watch how they work and see what they need done. Not look at what they're asking for, but look at what are they committed to? What are the outcomes they're going for? And then value can be ways that enable them to do this. So I talked about value streams. In my mind, there are four kind of value streams. One kind of value stream is like, I'll call it the discovery value stream of the organization, where you set up your strategies, where you're going to invest, what are your budgets, things like that. And that value stream, the company is actually the customer of that value stream. You've set that context. And then you give things to the developers, going to get, whether it's software, a product, or doers of it. And those value streams now have to focus on, how am I going to get this out the door? How's it going to be delivered? How's it going to be supported? But what you really want to look at is, how does it interact? How does what I'm building interact with the customer? The interaction of the customer's value stream, how they work with the system. The operational value stream is their full value stream, and the way they work with the system is what's called the customer journey. You use that to determine, you look at it this way, so you can say, oh, if I did this, I would be adding more value to the customer. And this is part of product management, is to use that. And then what you now see is the whole system: discovery, development, deployment, and support, and this operational value stream of the customer. You have to look at that whole thing. A quick example of this is the Sony Walkman. This is obviously way before Agile. Moretto, the CEO of Sony, just noticed that people couldn't get both music and exercise, mobility, at the same time. So nobody asked him for the Walkman, but he noticed that's what they were committed to. Some people for their health, jogging, some people for entertainment. And he had a personal experience because he traveled and liked classical music. So he saw, oh, if I could combine the two, mobility and music, I'm creating value for the customer. So a lot of innovation comes by looking at this question, how you do that.
And with that, Al, thank you so much for presenting with us today. We appreciate your time.
And thanks for having me.